Today I'm going to show you my solution to a tricky GCSE question which actually went viral a few years ago. It's the famous Hannah and her sweets question. After the exam, students flooded to the exam forums to vent their frustration over this particular question, with many students saying they had absolutely no clue how to go about answering it. There were newspaper reports of students crying after the exam and other students being very overdramatic by saying they will have failed their GCSE just because of this one question. In fact, this question sparked so much debate that it ended up trending worldwide. So, if you haven't seen this question before, let's take a look and see if you can follow along with me. So here is the question. It starts by saying there are n sweets in a bag. 6 of the sweets are orange and the rest of the sweets are yellow. Already this is sounding like my kind of question. I do love a good sweet. It goes on to say that Hannah takes at random a sweet from the bag and she eats the sweet. She then takes at random another sweet from the bag and eats that one. The probability that Hannah eats 2 orange sweets is a third. And we have to show that n squared minus n minus 90 equals 0. How do we get this quadratic equation based on this information that's being presented to us? Well, let's just forget about the quadratic equation for now, and let's just write down algebraically some of the things that they tell us in the first few sentences. Remember, we're told that there are n sweets in a bag, so that's the total. 6 of the sweets are orange and the rest are yellow. So we can straight away write an algebraic expression for the number of yellow sweets. It's going to be the total number of sweets, take away the orange sweets, and that's how many yellow sweets there are. Hannah takes at random a sweet from the bag and she eats it. Hannah then takes at random another sweet from the bag and she eats that one. And this question talks about probability. The probability that Hannah eats 2 orange sweets is a third. So the probability that Hannah would pick an orange on her first pick, let's just put first there, would be 6 out of n, 6 out of the total. And the probability that she would pick orange again, now think about how many orange there'd now be in the bag, because after she's picked the first sweet, she eats it. So there's now 5 orange sweets to choose, to select in her second pick. And the total is now n minus 1, 1 less in the total. Now, if we are told a numerical value of the probability of Hannah eating 2 orange sweets, how do we get that answer? So for that, we need to think about the and rule. We have a rule for and a rule for or in probability. And this is following the and rule because we're working out the probability that the first sweet is orange and that the second sweet is orange. And means to multiply in probability. So we're going to multiply our 6 over n with our 5 over n minus 1. And we have a numerical answer for that. It's a third. So we put that equal to a third. Now we've somehow got to make it look like this. Okay, so at the moment it's not resembling what they want us to, but let's just commit to the working, the rule of probability. We're going to times these together and see what happens. Don't be frightened with the fact they're algebraic fractions. They behave in the same way as regular fractions, and that we times the numerators together and we times the denominators together. So 6 times 5 is 30. And then the denominators, don't want to make any mistakes. So let's just write out those 2 denominators next to each other. Let's use a bracket, multiply the n with everything here, the n minus 1, so that we're not going to make any mistakes. So let's go all the way up here and do our working. So n times n is n squared, and n times minus 1 is minus n. So we get 30 over n squared minus n, and that's equal to a third. Now it's starting to look better because we've got a quadratic term on the denominator here, and we do need to get a quadratic equation. What we're going to do now is we're going to get rid of these denominators, get rid of the fractions. So we're going to times each side by 3, and then we're going to times each side by n squared minus n. Now, if I times this side by 3, I'm left with 1. So I need to remember to times the other side by 3 as well. And if I times the left-hand side by n squared minus n, it will cancel out that denominator. And then we need to multiply the other side by n squared minus n. So this is called cross multiplying. So 3 times 30 is 90. And n squared minus n times 1 is n squared minus n. And then we just need to collect everything to one side. So I'm going to take 90 away from the left and take it away from the right. So we end up with 0 equals n squared minus n minus 90 as required. So excellent. We've done part A. Wasn't too bad after all. So let's have a look at part B. We have to solve the quadratic to find the value of n. So we want to know how many sweets are in that bag to begin with. So in order to solve this quadratic, this was on a non-calculator paper, so you would be expected to factorize it. So if we want to factorize n squared minus n minus 90, and then solve it, we need to think of two numbers that multiply to make minus 90. And those two numbers have also got to have a sum of minus 1. So the two numbers have got to be consecutive in order to get a sum of 1 or minus 1. And I can think that's going to be a 10 and a 9, but we'll need to make the 10 negative. Negative 10 times 9 is negative 90, and negative 10 add 9 is minus 1. So we're going to put those in a bracket with n minus 10 multiplied by n plus 9. And here we've got a product. These two brackets have been multiplied together to give an answer of 0. So in order to get an answer of 0, at least one of the brackets themselves has to have a value of 0. So we can either say that the first bracket has to have a value of 0, in which case n would be 10, adding 10 to each side, or we would let the other bracket have to have a value of 0. So n plus 9 equals 0. Subtract 9 from each side. So n could be minus 9, or could it? Now, this question is a contextual question. So if we were just solving this quadratic, these would be two valid solutions. But because n is a quantity, the number of sweets, we're going to put a discard for this answer. N cannot be negative 9. N has got to be a positive quantity. So n is 10. There were 10 sweets in the bag to begin with.